All right, hello everyone, and welcome to this, the last session of the day for Ignite. I think this is the last session, right? It feels like it for me. I'm Marco Casalaina. I'm VP Products of Core AI and AI Futurist here at Microsoft. And what we're going to be talking about in this session is really what comes next, what is beyond where we are today. And we're going to give you a view towards that through the lens of Foundry Labs. Foundry Labs is kind of a forward-looking portal where we showcase a lot of the research that will lead to tomorrow's AI, including a lot of which is done in our own MSR, Microsoft Research. Microsoft Research has invented many of the things that we use today that we take for granted today, the methods that we use to train today's foundation models, the ways that we fine-tune it. These things were invented by MSR. And now we have Foundry Labs as a showcase for it. So I actually have no slides at all, and rather I'm just going to give you a view to Foundry Labs itself. Let's have a look at it. If I've pressed the right button. Maybe I didn't. Okay, this one. I swear this was working before. This is challenging. Oh, okay, I guess I'm on 2. That settles that. The tape does say 4, just for the record. Okay, I need some AI for this. All right, so Foundry Labs, and you can go to Foundry Labs yourself at labs.ai.azure.com. And so this is available to everyone. And here we show a lot of the latest technologies that we've been developing here, some of which Ashley is going to cover in a moment, so I'm not going to go into that. But some of these things, you can actually play with them now. For example, Trellis. Trellis is a research system now, and it's available as a GitHub repo that you can use where you give it a 2D thing, and it spits out a 3-dimensional representation of that picture. Now, fun fact about Trellis is, well, you can use it from the repo, but you can also use it in Copilot Labs. So there exists on the consumer side of Microsoft Copilot Labs. And so here, I use Trellis to make me this beautiful peach from this picture of a peach. Well, I also used it to make a picture, or to make a 3D representation of my own GitHub. This is my GitHub profile picture. I have never in my life had a handlebar mustache. In reality, I mean, the only facial hair that I really have is my eyebrows. But I've kind of always wanted one, so I used AI to do it, and then I created this wonderful rendering of myself out of it. So you can try this yourself at Copilot Labs, and there are some other things that you can play with, again, at Foundry Labs, labs.ai.azure.com. Now, one of the advancements that came out of Microsoft Research, and that is now very much in use, is the concept of an agent. Microsoft Research pioneered the notion of Autogen. And here I have one of my own agentic systems that I built myself. And I built this, by the way, to automate part of my own job. You see, part of my job is that I do all the analyst relations for Microsoft for AI. So when, you know, Gartner and Forrester and things like that, and also a lot of customer things. And a lot of times they send me these giant questionnaires like this. So I built this tool that is an agentic tool to help me answer these questionnaires. Now, at first, the first version of this, I had to paste in a question like this one, and it would answer it. This is a multi-agent system. And so I have, this is what's called a maker-checker pattern. I have a question answerer, an answer checker, and a link checker. But now, this is the third version of this tool, and now I can make it do the whole thing. This is actually a team of teams of agents. So if all goes well, there we go, in a moment, what you'll see is that now I have 3 different teams of agents running simultaneously on this spreadsheet. And so you can actually see them running independently, and when one of them finishes, it will go on to the next cell, and bit by bit, they will answer this entire spreadsheet. So this, I built this in the Microsoft Agent Framework. This is our new agent framework that we released in September. But the Microsoft Agent Framework can trace its lineage directly to Autogen and to the research that we did in Autogen around creating agents, around orchestrating multiple agents, and this is it in real life. So we have moved this product and this concept past that hump from research to production, to reality. And so now, from this point forward, we're going to have a look at what happens next, because these things that I've shown so far, these are research capabilities that we had that were in research before and that are in production today. But now we're going to talk about what happens next. And to talk about that, I would like to invite the CVP of Microsoft Research, Ashley Llorens. Welcome.
Thanks, Marco. All right, thanks a lot, Marco. You know, as Marco said, I'm one of the executive leaders at Microsoft Research. And as a research leader, I'm often asked to be present in customer meetings. And the reason for this is customers really want to know, as Marco alluded to, what's coming next. Customers want help seeing beyond the headlights. And that is becoming an increasingly difficult thing to do, given the sheer volume of innovations coming from the community, from Microsoft Research and other parts of the global research community, and the accelerated life cycle that we're seeing from research to product. And so what we've done is try to curate. We've partnered with our colleagues in Microsoft Foundry to actually curate a view for you of what's next. And so you saw the website that Marco had pulled up earlier. This is a little bit of a double click then on many of the innovations that are in there. And Microsoft Research has various innovations that you can peruse. All of them are available on open source, and many of them, an increasing number, are available on the Azure platform. So you can actually begin to pick them up and experiment with them in your Azure subscription. So what I want to do now is first tell you a little bit about Microsoft Research. Fortunately, we are not new at this game of helping companies see beyond the headlights. In fact, that's what we were chartered to do for Microsoft back in 1991. And that concept originated from a memo written, at least one of these gentlemen should look familiar to you, Bill Gates and Nathan Myhrvold, who was our CTO at the time. And even then in the early 90s, it was seen that the field of computer science was moving very quickly. And again, they needed a part of the company to look beyond the product roadmaps. And so our founder, an eminent professor we recruited from Carnegie Mellon University named Rick, he founded a team in Redmond, a few tens of people, and that's grown over the intervening time to a global research network with labs and locations on many continents around the world. And so what we do is we form a research ecosystem for Microsoft across all these various locations. And we also operate as part of the local research ecosystems that these labs are embedded in. And so we work with universities. We get the very best and brightest talent from that kind of global research ecosystem. And we work closely with them on research, even community organizations in these areas. So we operate as part of that global research community. We bring the best ideas back to Microsoft, work with colleagues like I have here to translate those into products. And you get a sense for the diversity of talent from computer science to social science and everything in between. Now, I referenced that kind of sheer volume of innovations coming, and just to give you a sense of that, if you look at the research publications from the last few years, and you look at arXiv, where many researchers publish preprints of their research, we've done on the order of a few thousand arXiv publications per year for the last few years. That's quite a bit of output, and on the order of hundreds of open source publications as well. And so again, we're really trying to help curate a view for you for what may be most relevant for you, and then to put more effort in to help you experiment with those things more quickly. Now, there's I think a mutual value proposition here. I've talked about what we think is a value proposition for you. It's also really helpful for us to mature research together with you. And so the signal that we get back from you in terms of what's interesting to you, in terms of the design patterns that you see emerging that can add value for you, that helps to inform our research roadmap. And so, the Autogen, an open source framework that Marco mentioned, is a great example of that culture of Microsoft Research, that empowered culture and that research to product motion in action. And so Autogen has its origins a few years ago, when most of the industry was really focused on kind of copilots and turn-by-turn interactions with copilots. Agents are a concept that really go back to the beginning of artificial intelligence in the 50s. But what these researchers saw was a near future where agents would become a primary vehicle for value creation from AI. And so they released that framework. It went viral in the open source community. Many hundreds of thousands of downloads, contributions from many open source contributors, and many at least in the open source realm, many projects taking dependencies on the Autogen framework. But importantly for this story here, this was actually matured together with customers as well, and you can see some of those enterprise customers there. And so that's the opportunity we have here to take this curated view, work together with the open source community, begin to work together with customers, try to understand what's next, work together on the research to product motion. So this is, again, that kind of broader view. And what we're going to do with the remaining time today is just preview a few of these things for you. Hope to get you excited about the curation while highlighting some of the things that you can do by engaging with us in this way. And so I'll cover two from Microsoft Research, one called Aurora, another called MMCT Agent, a multimodal critical thinking agent. I'm also going to show you one that originates from an external partner. As I mentioned, we operate as part of that global research ecosystem, and so some of these innovations will also come from partners. So to motivate the next two, I want to really share my conviction that perhaps the most important application of AI will be in the acceleration of the process of scientific discovery itself. We've been rate limited in a sense by the kind of traditional method of doing science, where we observe phenomena, we run experiments, we then create an analytic model that represents our understanding of some real-world phenomena, and then use that to create technologies. And the opportunity that generative AI offers us is effectively the ability to learn those models directly from data. So the actual understanding of the underlying phenomena, the model, is implicit and embedded in the parameters and the latent space of a generative model. And that offers us the ability to do things at small length scales, like discover new molecules that could be therapeutics, discover new materials that could be new equipment or more sustainable ways to create cement, and at the larger length scales to be able to understand our Earth system better and do things like predict weather and climate patterns. I'll start with, let's put our finger on proteins as a length scale of choice here to introduce 𝗦𝗲𝘀𝗀𝗀𝗀, a new model from the Institute for Protein Design at the University of Washington. So that's one of our collaborators. 𝗦𝗲𝘀𝗀𝗀𝗀 is a project that was actually led by them. We collaborated with them on it. Now, if protein design is interesting for you, this Institute for Protein Design has created an open source framework called AtomWorks. And so they're passionate about making kind of leading edge protein design accessible for more. So AtomWorks is a framework that you can find out on the web if you're interested in that. 𝗦𝗲𝘀𝗀𝗀𝗀 is a model that they use their framework to create that they say provides a leading performance on structure prediction for proteins. And what that is essentially taking the amino acid sequences in our genetics and predicting the 3D shapes of proteins that those instructions will ultimately create and fold into. And that's useful for a variety of applications in the life sciences. And so the leader of this lab is actually a recent Nobel laureate in chemistry, and I'll let him tell you a little bit more about it.
At a high level, our lab is interested in developing computational tools that let us understand the way that cells and living beings work.
The methods we're developing are all generative AI methods, so generative AI is really absolutely central to what we do. The models are being used in collaboration with researchers around the world to try and come up with better ways for predicting molecular interactions, designing new proteins, and as a part of our mission is to make all these tools available so that the whole world can benefit from them.
All right. Thank you, David Baker and team. Excited for you to get your hands on this model in Foundry if that's interesting to you. And now I'll ask my colleague Shannon to come up and tell you more about Aurora, a weather model that originates from Microsoft Research.
Thanks, Ashley. All right. So we know that the Earth is changing, right? Weather patterns are different, they are getting harder to predict, and they change more rapidly. So when we set out to look at that space, we saw that traditional numerical forecasting can't keep up with the changes that we're seeing. As a result, we started training an AI model that we think of as not just a weather prediction system, but actually an Earth's foundational model. It goes beyond the traditional data sets that you've seen in the other predictions. They're limited to being useful only for weather because of the fact that they are trained on the same weather systems over and over. Aurora goes further and actually understands the atmosphere. And so it can talk and evaluate and predict against the entire atmosphere's chemistry and some of the more complex interactions that you're going to see. What we got was a model that is absolutely phenomenal. It can predict 10-day global weather in under 60 seconds. This is something that used to take thousands of CPUs, hours to produce. I was telling Ashley this morning about when we look at aviation weather, that's published, those predictions are published every 6 hours, and they're based on the preceding 6 hours observations. So when you're flying in an airplane, your real-time data could be up to 12 hours old. Obviously, that's not an ideal situation. We want to be able to run that model much more rapidly. So we can operate on a single GPU to do this output. And of course, because we model the atmospheric chemistry, we get interesting things like air quality, pollution, nitrous dioxide, and ocean wave conditions. Sorry. So this was an example of one of the things that we did. I want you to pay attention here to the different tracks. By fine-tuning this model for hurricane and typhoon prediction, what you're seeing in the yellow was the official Hurricane Center predictions for 2023. This is Typhoon 𝗲𝗀𝗃𝗀. The green is the Aurora prediction, and the blue is the actual storm track. Our model predicted a landfall in the Philippines rather than Taiwan, and we predicted 4 days rather than the 5 that the official forecasts were showing. Now, this was all run after the hurricane to confirm it, but this year we've kept working on this, and what you're seeing here is our prediction for Hurricane Erin. And you can see that we tracked, again, much closer to the storms, much closer to landfall than the official predictions were making. And this matters because this was a massive storm with windfall mattering more than landfall for this particular storm. So we think this matters in a lot of different scenarios. We looked at a couple of different places. Agriculture, when you're producing crops, weather matters a whole lot. Logistics, navigation of ships, being able to be more fuel efficient as we move around. Retail, being able to predict long-term stock and changes in your market space. Aviation, we've already talked about. And another scenario that we've been excited to engage in is with our energy partners. Energy generation can be very complex. Energy consumption changes with weather, and grid resilience matters in weather. So our team partnered with an energy team here at Microsoft to talk to some energy partners. And we developed this particular application that actually shows us wind speed, air pressure, and surface temperature. It starts on the global scale, and then we can zoom down to Norway specifically, which was where this partner wanted to talk to us. How we did this super fast was with something that we call the 𝗦𝗲𝗀𝗀𝗀. That particular app was built in 2 or 3 days. What we've done is we've supercharged Copilot to understand this research. Weather forecasting is incredibly complex, right? It's hard to get this model down. It's hard to understand where to pull the ERA 5 data sets from. It's hard to do the training and inference. We've been able to teach Copilot all about this research and be able to do this very rapidly. So if you install the 𝗦𝗲𝗀𝗀𝗀, it supercharges Copilot, and you can do things in a much faster pace. In fact, that Norway app, we can now produce an example of it in about 6 minutes. This is one of my team members actually using the Copilot to redirect it towards Ireland. You can see we'll do the calculation of our coordinates, pull the appropriate data set from CDS, and then we can actually kick off the inference. And we can see here that our predictions were matching what we wanted to have. And it doesn't stop there. We actually have a team member who has been able to successfully fine-tune Aurora doing this. So now we can add new data sets. We can increase the accuracy. This is a particular surface temperature experiment that we ran. We're able to run through, and this took about 25 minutes, be able to actually fine-tune the model. We think we can expand this even further and add more variables and additional fine-tuning on top of this. This is a process that used to take us about a week to 4 weeks. And you can see here the tensor board outputs proving that our training is working. And in a moment, you'll even see the visualizations. So we're super excited about what Aurora means for weather prediction. This is a huge shift in the ability to predict weather, to be able to predict business scenarios. One of our partners is Teradot. They have actually a business model around enhanced rock weathering. This is spreading silica on soil in order to remove carbon from the Earth's atmosphere at a gigaton scale. They're working with Aurora, they're fine-tuning it, and they're engaging with us to be able to do their work at a much more rapid pace. And so with that, I'd like to say, join us. We've actually released the repo for the GitHub supercharging through 𝗦𝗲𝗀𝗀𝗃 today. You can download and engage with it through the Foundry Labs and actually start your own weather experiments at home. Ashley?
All right, thanks, Shannon. Well, I'm going to close us out by sharing a bit more about a video analytics tool, an agent framework for analyzing video, with an interesting origin story at Microsoft Research. And so part of what we focus on is helping the company really realize the mission to empower everyone by looking at parts of society that may not really be in the flow of innovation from AI and really be able to benefit from that as we can in our parts of the world. And so this shows up, for example, in Global South nations, folks that may speak low resource languages, that is, languages that aren't well represented in the training data sets for AI. And we really try to understand how those communities can benefit from AI and then work to channel the innovations in a way that tailors it for them. And here you can actually see one of our team members sitting down with a farmer in Kenya. One of the patterns that we've seen in some of these low resource settings, as we've done the deep social science and user research here, is the growing importance of instructional video. And so from a cultural standpoint, in these parts of the world, oral tradition is very important, community media is very important, and a lot of the way that knowledge gets passed on is through instructional videos, like this woman here providing some instruction for agriculture, and this proliferation of agricultural instructional videos from these folks. And so this is a design pattern that really inspired the creation of the multimodal critical thinking agent developed by a collaboration by our teams in India and Africa. And so here what you're seeing is essentially an agent scenario where you've got a corpus of instructional videos and someone that wants to get their question answered by reasoning over that corpus. Now that's not actually a strong point. Reasoning over a multimodal corpus like that, that's not a strong point for current foundation models. So this system works with base models like GPT-4 or 5 to augment them. And you see a question here of someone asking, what kind of cloth is used for sieving okra seeds? So this is a kind of filtering process. And what the agent does here is it actually reasons over this indexed corpus. It analyzes the video content. It retrieves relevant segments of the video content. And then what it does is it returns the answer in their language of choice, and it also brings them to the relevant parts of the video, so it answers their question in a multimodal way with both text and video. Under the hood, there's a pre-processing step where content ingestion is done. So again, you're starting with a corpus of training videos. The team is using Azure AI Search together with some specialized multimodal video ingestion and interpretation agents developed by Microsoft Research. And then in real time, there's a Planner-Critic architecture where the planner essentially reasons over the data set in a multimodal way. The critic assesses the quality of the answers, and it's iterated on until the answer is given. And so this is not, it's research, but it's also been deployed with our partner Digital Green through this app called Farmer Chat. And so we've actually observed a significant improvement in the user satisfaction with the answers they're getting back using this multimodal critical thinking agent. And I can let the CEO of the company we're working for, this nonprofit, kind of speak for himself here. But what the farmers really appreciate is getting real-time responses to their queries in their own local language and in a multimodal way. And a fun fact here is, MSR releases publications, we do research the product, but sometimes we spin out companies, in this case a nonprofit, and Digital Green actually spun out of our lab in India. And so that's a little fun fact for you there as well. So please feel free to explore this. Although it has this interesting origin story, what the team is really excited to explore, perhaps with some of you, is what the more general applicability of this tool might be for those that multimodal reasoning over instructional videos may be very helpful. So once again, these are a few examples. You can peruse the site. You can see this curated view of research. You can experiment with them. If you're an open source developer and you feel confident, just take the repo and get started. But if acceleration is helpful for you, then some of these have vibe kits of the kind that Shannon was talking about to help you begin to experiment. And in some cases, we run early access programs where we actually work together with a subset of companies that are very interested to help them experiment as well. So these are some of the things you can do. And with that, I'm going to invite my colleagues back up, Shannon and Marco, and we'll take your questions. All right, so I'll maybe take moderator's privilege, and I'll start here with a couple questions. So Shannon, you talked about the vibe kit that you made for Aurora. How do you choose which of these projects to make these kind of accelerators for?
That really comes down to signal feedback. It might be internal excitement about the project. It might be external. It's market trends. Marco, you're one of the factors in that, whether you're excited about the research. But what we do is we monitor a lot of the GitHub repos. We monitor the blogs. What kind of community engagement are we seeing against a particular research project? So the more you get involved with Foundry Labs, the more you comment, the more you open issues, that's going to be a signal for us on where we're going to invest in those accelerators.
Thank you, Shannon. And Marco, maybe a fun one for you. So you introduced yourself at the beginning as an AI futurist. What does that mean? And are you the only person with Microsoft with that title?
As far as I know, I am the only person at Microsoft with an AI futurist title. And what it means concretely, at least for me, is I get to be the first person to play with anything new. So everybody always gives me the new stuff, and I hammer on it until I get it to work.
Wonderful. All right, now for your questions. There's a microphone right in the middle of the room. I'd ask you to come on up and fire away.
Please step right up.
That's really impressive work with your weather modeling and the way that you're actually able to account for climate change where things go outside of the historical standard. When it comes to working on these kinds of things and interacting with the standard authority like the United States Weather Service, are they excited about these things, about the work you're doing, or are they worried about the non-deterministic nature of AI?
They engage. I think there's obviously, weather matters a lot. This affects millions of people's lives. When an evacuation is ordered or missed, that's life and death consequences. So I think at this point, obviously, the government's going to take an appropriate stance when we engage on that. But they are very receptive. We have multiple engagements right now around the globe with prediction centers that are looking at the models, understanding how they work, and comparing the results for themselves. That being able to rerun those conditions or those predictions so fast is a huge benefit for Aurora. So think about, you've obviously had days where it's supposed to rain tomorrow or whatever, and it rains today. That's when that cold front accelerates as it's moving across, and that was an unpredicted set of changes. And again, because you have that latency in how often you can run the predictions, nothing gets updated fast enough to recognize the changing conditions. Hurricane Erin went from, I think it was category 3 to 5 in a matter of hours because of the temperature of the ocean under the surface. Those sorts of changes are super hard to predict with the existing models. because we can keep rerunning, we can take those observations into account and make a difference. And so that's where I think, yes, we get engagement. They are interested. They are excited. And I think there's going to be some more news on that soon that I'll just nod and let Ashley answer.
Oh, well, look, I don't want to speak for any of our customers and partners, except to say, as Shannon mentioned, that they are engaged with us on this. But I'll just share my own view that this is a saying that I often come back to. All models are wrong. Some are useful. And so I think that the comfort of traditional models in weather or anything else is that they represent our explicit understanding of these phenomena, and they're constructed. And so that's the comfort of a model like that. But they're not perfect. They involve assumptions. They involve sometimes numeric optimization. And so those have their trade-offs. Generative models have their strengths and weaknesses relative to traditional computational models as well. They're more scalable. They can learn from data. We're amortizing the cost of computing, right? So we're putting a lot of resource into training, and then the inference is relatively quick. So the distribution of the computational expense is kind of different in that way. And so, I think most weather services today are seeing the strengths and weighing the strengths and weaknesses of these different approaches, and probably want the best of both at the end of the day. Again, not speaking for them, just sharing my opinion.
Thank you.
All right. Other questions? I thought I saw somebody else raise their
Other
hand.
questions?
It's 4 o'clock. They're all done.
I know.
Well, look, if not, we can give you a little bit of time back, but we'll absolutely hang around and would be happy to answer any questions you'd like to hit us with after the session. So thanks once again to Marco and Shannon and to you for spending this last session of Wednesday Ignite with us. Thank you very much.
Thank you all.